In this video, we're going to talk about how to differentiate a function by using logarithmic differentiation. Pretty much you apply logarithm to both sides of that equation to find the derivative. So suppose this is the example and you want to find the derivative of the function, so y prime, or you can call it dy dx. So something you want to keep in mind as you're using this method is to remember what the derivative of the following is. So if you want to differentiate, let's say, ln, so we're going to be using natural log ln of x. Well, we know that's 1 over x. That's the derivative of ln of x. And if you have, let's say, ln of u, where u is a function of x, then this is 1 over x, 1 over u, whatever is inside ln, times the derivative of u, du dx. So these are the two formulas you want to keep in mind as you're working on logarithmic differentiations. So you take the function, so on the left side we have this function y equals square root of x times x plus 1. Now what I'm going to do is I'm going to rewrite the function this way. So my formula is y equals, I have x times x plus 1 to the power 1/2. I wrote the radical as 1/2. And now I simply take logarithm on both sides. So here you're going to apply our natural log to both sides. So apply log on both sides. And once you do that, you're going to use the laws of logarithm to simplify. So let's go ahead and do that. So if I apply logarithm on both sides, so natural log, that's ln of y. And on the right hand side, you're also applying natural log, that's x times x plus 1 to the power 1/2. Now by applying the laws of logarithm, so one of the laws of logarithm tells us that if you have, let's say, ln of a times b, that is simply ln of a plus ln of b. Second laws of logarithm tells us if you have ln of a over b, that's simply ln of a minus ln of b. And the last laws of logarithm, if you have ln of a to the power c, that's simply c times ln of a. So you also want to keep these laws in mind if you're using logarithmic differentiations. So using the third rule, I can treat 1/2, well, that is an exponent, I can bring that forward in the front of the logarithm. So that simplifies my function to 1/2 ln of everything inside. And I can still simplify this a little bit more by looking at what's inside the logarithm. Well, that looks like product of two things. So you can use this rule right here to separate. So think of a is x and b is x plus 1. So this can be simplified a little bit further. So it's 1/2 times, don't forget that, the 1/2 belongs to everything inside. So that's ln of x plus ln of x plus 1. That's how it looks like when you separate them. And now I can distribute the half out if you want. You will have ln of y. So just a lot of rewriting before even differentiating. So this is 1/2 ln of x plus 1/2 ln of x plus 1. These are the inputs, so I'm putting them as parentheses. Now we're ready to differentiate. So now take the function, all of this, and we're going to take the derivative of this respect to x. So it's going to be an implicit differentiation. So we know derivative of ln of y, that's simply 1 over y times the derivative of the inside, well, that's dy dx, implicit differentiation. And then you differentiate this. Well, we know derivative of ln of x, that's, so I have a 1/2 times the derivative of ln of x, that's 1 over x, plus the second one, now you differentiate that. Keep the 1/2 in the front. So derivative of ln of x plus 1, that's simply 1 over x plus 1, all of the inside, times the derivative of the inside, well, that's simply 1. So I'm kind of using the chain rule that you see right up here. And now just simplify that. So this is equal to what? We're solving for dy dx. I need to isolate that. So before I isolate, I'm just going to rewrite. So I have 1 over y times my derivative dy dx is equal to 1 over 2x, I can join them, plus 1 over 2 times x plus 1. And now I'm solving for dy dx, that's the derivative. I simply multiply both sides by y. So multiply both sides by y to get rid of the y from the left-hand side. And that gives you your derivative, dy dx is equal to all of this 1 over 2x plus 1 over 2 times x plus 1 all times y. Well, what is y? Well, y was given in the problem. That's just all of that. So let's substitute that in there. So our final answer is simply dy dx is equal to all of that in the parentheses, 1 over 2x plus 1 over 2 times x plus 1 times y. Well, y is square root of x times x plus 1. So that will be our final answer by simply using implicit differentiation along with logarithmic differentiation. Now you could have approached this problem by simply using chain rule and product rule once you wrote it in this form, and try to compare your answer, and you'll see that that's same answer as we got for this part right here.